Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever. And today we are talking about probability. Got some diagrams on here, pretty interesting. Especially this one over here. Pause it if you want and take a look. Little examples of probability in our world. Okay, experimental probability. In a nutshell, what is experimental probability? Well, it's probability based on an experiment that has been done. And so we make predictions, or we give the probability based on the results of the experiment. The thing they have here is they have a small plastic cone tossed in the air, and they're saying in this experiment 279 times it fell on its side like this, and it was thrown 279 times, and out of that 279, 183 times it fell on its side, and then 96 times it fell on its base. Okay, so based on that, we can get some probabilities. An experimental probability is the relative frequency, the frequency of which an event occurs. And so what we can say here, this is the same thing that was there before without the title. The experimental probability of the cone landing on its side is equal to 0.656. And where did we get that from? Well, the 183 times it landed on its side out of 279 is about 0.656. And the probability, the experimental probability that it lands on its base is 96 over 279, or about 0.344. The larger the number of trials, the more confident we are that the estimated probability will be accurate. So if we did this 1,000,000 times, we could get a very good idea of the probabilities, although 279 times seems to be pretty good. So basically, experimental probability is probability based on the results of an experiment. What is sample space? Well, sample space U for universal set is a set of all possible outcomes of an experiment. It's also referred to as the universal set U. Duh. And there's lots of different ways we can list sample spaces. Okay? For example, list the sample space of possible outcomes for tossing a coin. Well, tossing a coin, you can get heads or you can get tails. So the sample space would be, if you put it in set notation, H for heads, T for tails. And what about the sample space of possible outcomes for rolling a numbered or normal die? Well, 1, 2, 3, 4, 5, or 6 are the possible outcomes. Easy peasy. If only it was that easy all the way through. Use a two-dimensional grid to illustrate the possible outcomes when two coins are tossed. This is a nice, it doesn't seem necessary right here, but as we move forward, a two-dimensional grid is a nice little way to do things. And let me show you how that works. Let's see, I'm going to do this. Well, you know what? Here's what I should do first. I'm going to list the possible outcomes along each axis. We could have toss heads, or we could toss tails for the one coin, and we could toss heads, or we could toss tails for the other coin. Okay, so we do a horizontal line for the tails and heads on the vertical axis, and then a vertical line here. Yes, for the heads and for the tails. And then where they intersect represents all the different possible outcomes. Okay, and what are they? I'm going to make little points there. There's 4 possible outcomes. This intersection here represents, we could toss heads followed by a heads. We could toss heads followed by tails, heads, tails. That's this guy. Maybe I should put him here. Heads, tails. Heads, heads, tails, then heads, and then tails followed by tails. And the intersection points gives you the number of possible outcomes, and you can easily fill them in. We can also use a tree diagram to find possible outcomes, tossing 2 coins. Well, we always start with a V or an arrow or less than symbol, whatever you want to think, or however you want to think about it. So if I toss a coin, it's either going to come out heads or it's going to come out tails. And then if I toss a second coin, well, the second coin could also come out either heads or tails. Okay, so heads, tails, heads, or tails. So I could get heads, 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 tails, tails, heads, or tails, tails. What about drawing two marbles from a bag containing many red, green, and yellow marbles? What would that look like? Well, if, oops, better post them videos. So, what are my possibilities? Well, I reach into the bag and I could draw one of three colors. So I need three segments for my first tree diagram. I could draw a yellow marble, well, let's do it in their order, a red marble, a green marble, or a yellow marble. Those are the possible outcomes. Okay, let me move that out of the way. Okay. Nice little art, huh? Not bad for an old guy. And then I'm going to draw a second marble, and I could draw, again, they said there's many, so I can assume there's more than one. I still have three more possibilities, don't I? One, two, looks like bird's feet, don't it? Doesn't it? What was I, born in the barn? Actually, I was, but that's a different story. Okay, so this represents all the different possibilities. So again, since there are many red, you know there's more than one. We can safely assume there's more than one. So we have red, green, or yellow. After I choose a red, after I choose a green, I could choose red, green, or yellow again. And after I choose a yellow, I could choose red, green, or yellow. And you can see all the possibilities. The possibilities are red, 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 green, red, yellow, in that order. We could also get green, then red, green, 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 yellow. And I hope you see what I'm doing here. Green to yellow, green to green, green to red. Yellow, red, yellow, green, or yellow, yellow. How about them apples, boys and girls? Okay, next is theoretical probability. And I think I'm going to stop right there and we'll just make a short video to finish this up. So that, boys and girls, is all I've got. Let's see what's playing on the tunes. Oh yeah, Funky Town. We shall see you next time. I am out.